factorize this cubic expression. So we factorized quadratic equation using splitting the middle term. But we can't do the same at one go with this because there's no middle term to split. So how do we go about? First is we will start off by writing in standard form. It looks to be in standard form, so I guess it is not an issue. 1x cube minus 2x square minus 1x plus 2. And the next step would be using factor theorem. Why should we do that? I'll explain. See, factorizing this, there are two methods. The first method is, which you can rely on, which is easy comparatively, using factor theorem. And then we have to divide. There's some division, and then we will use splitting the middle term. The second method is same factor theorem, and then we will something, this is a bit weird, taking common and then splitting the middle term. Okay, this is all good. So what next? We have to we'll have to start with factor theorem. Okay, so these are your methods. I'm going to use second method. So as per that method, we have to use factor theorem. So first thing is we'll use factor theorem using factor theorem. So before we use the factor theorem, okay, I would like to make you guys understand this. Actually, more than understanding, it is a process that you guys have to remember. You have to check if the coefficient of x cube term is 1. If you need to make, if not check, if it's not 1, then you have to make it. How do you make it? I'll explain it in some other problem. Okay, it's not possible over here. So we have to make, if not check, if x cube coefficient is 1. In this case it is. So you need not do extra step. Directly you can jump on to step B, that is using factor theorem. So for that you need to write the constants factors. So what is the factor of 2? Plus or minus 1, plus or minus 2. These are the factors when it comes to integers, right? These are the integer numbers which can divide 2 with a remainder 0. Now out of these 4 numbers, pick one which you think can make this entire expression 0. That is p of x is equal to, what do you think will make it 0? I think 1. So 1 into 1 cube minus 2 into 1 square minus 1 into 1 plus 2. So further solving it, 1 minus 2 minus 1 plus 2, which is equal to 0. What does it mean? This particular term, not term actually, this particular value makes the remainder 0, right? It makes sense. I mean, that's what we did. So with this, what can we find? We indirectly found the factor. Say x is equal to 1 or x minus 1 is a factor. How did I tell that? Think about it. X minus 1, if it divides p of x, the remainder will be 0. How did you tell that? With the remainder theorem. So what is the 0 of x minus 1? My question to you guys is, what is the 0 of x minus 1? So all you have to do is equate x minus 1 to 0 and x is equal to 1, right? This value I've substituted over here and I got a remainder 0. So what does the factor theorem tell? This particular expression is a factor of p of x. That's it. That's what we did. We did the other way around. Again, you'll get used to it. Don't worry. It's not too difficult. This entire chapter is lengthy and difficult. Right? There are too many things. You have to get used to it. There's no other way. Okay. So just see the process. You'll understand things in time. Third step is I'm going to use taking common. If not, you can do the division. Either do the division or you can do this if you understand. Okay, so yes, it will be a bit weird and difficult. I'm going to tell now itself. But once you do it on your own, it will become simpler. Okay, so what is that we have to do? I have to get x minus 1 common from all of these expressions. How? Well, by doing this. 1x cube. From 1x cube, I have to take x square common to get x and minus 1x square. So from this too, I'll get x minus 1, right? Think about it. If I take x square common, I'll get x minus 1. Like if I take x square common, I'll get x minus 1. Correct? So, but where did this pop up from? This came from minus 2x square. That is, I can rewrite minus 2x square as minus 1x square minus 1x square. Okay, kind of makes sense. Again, I got minus 2x squared to split into minus 1x square and minus 1x square. How did I decide on that? Because I wanted x minus 1 common. So as per this term, I am doing things. Next step. From this 2 I got x minus 1. From the next 2 I want x minus 1. For that, here I need to have plus 1x. By taking minus 1x, I'll get x minus 1. Think about it. Does it make sense? If I take minus 1x, I'll get x minus 1 from this. Okay, this came from minus 2x squared. But how did we get plus 1x? That we got it from minus 1x by writing minus 1x as plus 1x and minus 2x. If you are able to understand this, you are done. Okay. And last, you just copy the last term. And the last two terms, what is common? Minus 2. And you can write this as x minus 1. Now have a look at it. Right? So with all in all, we have x minus 1 as common. And what is remaining? X square minus 1x minus 2. Okay, if you're not able to do this, you can go to division. It's the same thing. Okay, so we'll get the same expression at the end. So this will be your quotient, x squared minus 1x minus 2. So again, this is by splitting the two terms which are in the middle. Yes, it is kind of not the same thing. Yeah, but yeah, yes, we are trying to, in splitting the middle term also we split, right? The same thing. But we have to be smart and do it. So the best way to go about doing is copy the first term, write the second term that is required so that you get x minus 1 as a factor, common factor, and manipulate the next term or write the next term so that when you add this 2, you should get back whatever is over here. Same process 2 times. That's all. To be frank, more than division, this will save time. And if you get used to it, it's very simple. First time when you do it, it's confusing. But next time it's very simple. Again, you need to do it on your own. if you read a book, if you see a video and then, okay, this is how, what you should do. If you come to such conclusion, it won't help. Take a problem, try to do it on your own. If you are able to handle it, then you have learned it. If not, you have not learned it right. Okay, so you have to think and do it. So explaining it will make you understand for that problem, but for the next problem, you won't be able to do it. Now, the next step, I think the fourth step, is splitting middle term. Which middle term? G of x, which is equal to x square minus 1x minus 2. So how do you split? We need two numbers, which when multiplied should give me 1 and minus 2, that is minus 2, which when added should give me minus 1. So what are these two numbers? Well, let's write factors of 2. Plus or minus 1, plus or minus 2. So these are the only combination. So it has to be 2 and 1. Well, 2 and 1 will not give me minus 2. If I take minus 2 plus 1, it gives me minus 2. That's good. Minus 2 plus 1 will also give me minus 1. So we are done. All we have to do now is 1x square minus 2x minus 1x, sorry, plus 1x minus 2. See, it's the same thing. We wrote minus 1x as minus 2x plus 1x. The same thing is done over here. We wrote minus 2x square as minus 1x square. And minus 1x as plus 1x minus 2x. Again, why do we need this? That is, that is where you guys have to figure out. Okay. So we have, between this two, we have x as common factor. I mean this, and here it is 1. So x minus 2, and over here it is plus 1. Either minus 1 or plus 1 has to be taken because there is nothing common, and you end up with this. So at last we have x minus 2, that is common between these two, and you have x plus 1. Okay, so by splitting the middle term, we found the factors of p of x indirectly. So we end up with p of x having x minus 1, x minus 2, and x plus 1 as its factors. Okay, so this is your answer. Again, I'll repeat. Always start with your standard form. Next, you can use either of this method wherein you have to use factor theorem. So before we talk about the factors of the constant, you always should see to that your coefficient of the highest term, that is x cube, is 1. If not, there's a way to go about doing it. I'll teach that later. I mean, in a problem wherein it's not 1. Then once you have 1 over here, look at the constant, write the factors. And then you go about, trying each one out. So in this case, x is equal to 1 minus 1 plus 2 minus 2. Okay, so you do this and you figure out, okay, sometimes you will get remainder which is not 0. It's okay. You continue with next possibility. Right? Try to do the best possible value at first go itself. If you're not able to get it, it's okay. But in this case, I happen to get it. So I was able to figure out that x minus 1 is a factor of p of x. So how did I come to a conclusion that x minus 1 itself is a factor? Because x is equal to 1 was the value which made the remainder to be 0. And so by reverse technology or method, I found x minus 1 is the expression which has the 0 as 1. Again, the previous section has to be learned properly to understand this. And in the third step, we have to take common. So taking common it gets weird. So the middle two terms we need to split to get a common factor of x minus 1 from all the expressions. Okay, so you start with the first term and write the next term so that you get x minus 1. Write the next term so that when you add, you should get the one of the this particular expression, x square expression, and write the next term over here so that you get common of x minus 1, and write this term so that when you add this you get back this particular term, and write the constant. So once we're done with all of this, take common and then again take common, and you have your expression. So end of it, you need to split this term to get back, to get your answer, not get back, to get your answer. Right? So this is your entire process. Again, this you need to learn the previous section. This is from previous section. From previous section. Previous section concept, to be frank. Okay, let me write it properly. Previous section concept. Okay, so you can pause and have a look at the answer. So to end with, let's have this particular cubic expression on a graph. So I have already typed in your expression x cube minus 2x square minus 1x plus 2. That's your question, right? You can have a look at your book. It's the same expression. So let me execute this and we have a graph. Okay, so this is a sample of a cubic expression. That's how the graph looks. So you can see a frowny, almost frowny, and almost smiley face. Both are there in cubic. In quadratic, you see a frowny face, if not a smiley face. Now, what else can we observe over here? So to have a frowny face and a smiley face, we need two bendings. So one bending is over here and the second bending of the curve is over here. In quadratic, there is only one bending. In cubic, there are two bendings. So in linear, there are no bendings. So if you start with linear, no bending. Quadratic, one bending. In cubic, there are two bendings, sorry. So one less than the degree. And then we have one more interesting thing. The point where the graph crosses the x-axis. It is crossing -1, 1 and 2. This value can be seen over here. Where, look at this. Sorry, not. What is the zeros of this set of expressions? X minus 1, 0 is 1. This is 2 and this is -1. That is, if I put 1 over here, it becomes 0. If I put 2 over here, it becomes 0. And if I put -1 over here, it becomes 0. So your values are -1, 2 and 1. So basically P of x is 0 is -1, 2 and 1. Or -1, 1 and 2. So you can see over here -1, 1 and 2. So that is your 0 of this particular cubic polynomial. Right? I hope you are able to match the values that you get mathematically by algebraically and graphically. You should be able to match. Graphical interpretation and values, understanding and all of this is very important for statistics, for business studies or any kind of analysis which is data oriented. You need to learn to read a graph. Okay, so that's why all of this emphasis on linking this two topic, right? That's why I'm trying to link so much. Okay, now you can pause and have a look and copy it off.